Hi, it's James Governor, co-founder of RedMonk, and we're here for another Conversations with RedMonk. And today I've got Dave Brown, General Manager of EC2. We've got an interesting topic ahead of us, which is looking at the specialized instance, the Graviton 2 instances. Good place to start, I think, is always with a story. So Dave, why don't you tell a bit about your journey at Amazon, how you got to where you are, what it's like to manage a business like EC2, and then we'll head on into some of the specific content for today.
Great, James. Well, thanks for having me. It's really great to be here. I joined the Amazon EC2 team back in Cape Town, South Africa, about 14 years ago. Actually, almost exactly 14 years and 2 days ago now. And I was actually a software developer. So I joined and wrote a lot of the early code on EC2. So, some of the early features, like when we introduced availability zones, we introduced some of our very first instance types, support for elastic IPs.
Yep.
I wrote a lot of the code behind that. It was a super small team at the time, based in Cape Town.
So it's all your fault.
It is all my fault. A lot of those features. Actually, the team actually calls that out quite a bit. They actually often still find some of my code in the repos and say, "Hey, Dave, we found some of your code and we understand now why you're a manager." So you don't succeed, try management. So
yeah, I mean, I've got a friend of mine, Ant Stanley, does a lot in the serverless group. He's from Durban, but obviously South African mafia, and so he always speaks very highly of that team and the work you did, and he's proud of it. I mean, it's a story that not everyone knows, but yeah, some very important code written there.
Yeah, we honestly, had very little idea about what EC2 would become over the years. We kind of had an idea what we were building, but it's really been an incredible journey to see where it's been. So, I'm still a developer at heart. I still, get a lot. I don't unfortunately write a lot of code anymore, but I get into a lot of the details all the time. And, over the years, I just sort of picked up more and more of EC2 as I moved into a management role. And today I lead the EC2 organization. So it's all the compute and networking services that make up EC2. It's a lot of fun. What I really enjoy is really two things. One is my customers are developers, and that's who I am. I'm passionate about writing code. I'm a passionate developer. I'm passionate about distributed systems, building large, innovating, and allowing my customers to innovate. And so that's really nice because you really do understand your customer well in that situation. And then the other thing that's a lot of fun is just the pace at which we move. We're known for moving at a really fast pace. And so being able to innovate at that pace for our customers is always very exciting.
Does it ever get a bit frustrating? Because it's sort of like, EC2, everyone's like, well, we use that. We already know about that. Like, what's new? Like, what are you talking about? That's not the new stuff. Do you ever sort of feel like, everyone's wanting to talk about some cool new service and you're just part of the furniture now?
I thought we'd be done with the roadmap like maybe 6 years ago. I didn't think we would still be finding new things to build in EC2. And it's honestly, when we look at our roadmap today, it's really early days. When you look at the new stuff, there's amazing new stuff, right? Obviously, containers is a big part of that. There's serverless is a big part in the compute side. A whole lot of higher level networking features coming out. There's always the new stuff, but serverless actually probably something I shouldn't tell your audience, but there are servers behind serverless. And so, we still get...
You've just started a massive flame war again there saying that.
It's top secret on the AWS side, but, we're still very involved with the Lambda team, helping them build what they build. And, customers still want to discuss, at the end of the day, their architecture, whether it's a network topology, or it's, how they want to use the different compute instances, what we have on the roadmap. It's really just an opportunity for, us to geek out with the customer on what they're building and how we can best support them. So I'm never bored in my role at all.
Okay. So instances, clearly a big part of the innovation has been different kinds of instances. We're here to sort of talk about the Graviton 2 processors, specialist processors. It's not new that Amazon is building specialist processors, though, is it? This has been a journey as well.
Yeah, absolutely. We actually started the journey in the early days of EC2. If you look at where we started, we really just took Zen, and we used Zen as a hypervisor, which runs on the central processor. It was Intel back in those days, and that's how we did virtualization. But at around 2009, 2010, we started to realize that we had to find a better way. And the big problem was, if you remember those days, there was too much jitter in the network, right? Your performance would be great, and then you would see a 300 millisecond spike, and workloads would never be able to run in the cloud. That was the case. So in 2012, we actually started to look at, was there a way we could take the software that traditionally ran on the central core and actually move that onto hardware acceleration. And obviously, when you're doing hardware acceleration, you need some sort of processor. And so we looked to ARM back then. In 2014, we ended up buying Annapurna Labs. It actually made processors. And so we've been working on processors since then, building these little processors that actually run on what you'd call sort of smart NICs, maybe, offload cards. And in 2017, we actually launched our very first EC2 instance that had 100% of all of our code. So whether that's network, storage, security, all the control plane, billing, firewalls, everything actually running on these offload cards. And 100% of that central processor we were able to give to the customer. And that was what we call the Nitro system, which was an enormous step forward for us, in terms of performance, just raw performance. We get much better performance with the Nitro system. Being able to give 100% of that core to our customers is a really big benefit for them, and the memory. So we're not using any of those system resources. But that started the journey for us. Once I've got engineers in my team writing for ARM, we started to think maybe there was something in this that we could bring to our customer base.
Okay. And why should developers care, though? I mean, it's sort of, okay, it's ARM based, but what's the big deal? What's the thing that should make people say, actually, it does make sense for me to be thinking about these particular instances? And particularly in a world where you've got like 400 different kind of instances, you've got a huge number. There can be a bit of choice anxiety or even an overhead in being like, where should I run this? So how do you guide the developer or user through that? And what in particular is the benefit statement at the moment that might get people to think, I need to do this now?
Absolutely. And I agree with you completely. It's a great question. There has to be something big for them to go and do the work and say, hey, let me consider a different architecture. And that's something big for us is a 40% better price performance improvement over what you would get with an x86 processor. And that 40% is not some benchmark that we've concocted on the side where this, the settings have to be exactly right to actually get that. We came out with 40% because we actually see anywhere from around 30 to 50% improvement for sort of most workloads, just a broad set of workloads. You mentioned the 400 instance types. We actually just crossed 400 instance types earlier this year. And it's just crazy. Remember the single instance we had 14 years ago, and we've just been adding instances over the years. And that's really just listening to our customers, hearing what types of workloads they want to run on EC2. And then being able to support them in that. And so we ended up with 400 instances now. And ARM's huge for that, right? So, we're actually bringing out ARM-based or Graviton 2-based instances with our Graviton 2 processor across a number of our different instance types. So you're able to get them on our compute optimized, our memory optimized, our storage optimized, you'll have them there. And so we're looking, across, we've recently launched one with memory optimized with up to 1 terabyte of memory. And so just a broad set of workloads. And then knowing that when you port, you're able to get 40% better price performance. It's just a huge benefit.
Shouldn't we just all switch everything else off then? It sounds like a done deal, isn't it? 40% price performance improvement.
One of the things we're excited about is obviously there's workloads that are going to continue to run on Intel and AMD. And we partnered very closely with Intel and AMD. We still have obviously an enormous number of Intel and AMD processors in our data centers, and we expect that to continue for the future. What we are excited about, though, is being able to put something out there in the market that really shows us that Moore's Law, maybe in Moore's Law, it died back in the early 2000s, and we kind of just started to accept, hey, well, 10, 15% performance improvement is what you can get generation over generation now. And with Graviton 2, we're excited to change the story on that and say, hey, yes, 40%, and hopefully more improvements going forward, and that customers and developers should expect more from their processor.
Okay. And so I was being obviously a little bit flippant about turning off your the processors from your valued partners. But let me ask a question, because one of the new kingmakers, if we're going to talk about developers making choices, is you need to be supporting all of these stacks on the specialized silicon. And as we saw actually with Apple in terms of development machines, everyone's like, wait, I can't run Docker on this. There is a tool chain, there is an expectation, there's a fair amount of work to be done there. So I'm interested in questions about barriers to entry, but also the ecosystem and how we get the ecosystem, like what runs on there from an open source perspective, what expectations should I have? You say I can choose to run the workloads that I've got on Amazon, some Amazon services at the moment, but tell me a bit about barriers to entry or the lack of them, and whether I need sort of specialist skills in order to take advantage of these instances.
You're absolutely correct. And one thing I didn't mention is it's Graviton 2, because this is actually our second Graviton processor.
Hmm.
We launched the very first Graviton processor back in 2018. And we actually just took one of those processors we were using internally on an offload card, and we provided it as a server chip. And I remember sitting in discussions about that. And, we were saying, who's really going to use this? And we were like, well, maybe some university project and some research, because we didn't know how, Graviton would be accepted. And obviously just the adoption was just, much, much larger than we expected, which is really exciting to see. But the reason we ultimately put it out there, a year before we actually brought out the real Graviton 2 that we'd been working on for several years, was to spark the ecosystem. It was super important for us to be able to say, hey, Arm has been in the mobile space for a long time. It's now in the server space. And you, as an ISV or an operating system vendor, you should start thinking about your support for Arm and for Graviton 2 and Graviton, obviously Graviton 1 back then. And so that's what's happened. And, we were pleasantly surprised in that year just how many ISVs actually ported over. The vast majority of Linux-based and BSD-based operating systems now support Graviton 2. And so, you can go to our image selection and pull up a number of different images. And the great thing about that is for the most part, the operating system shields you from the architecture. And so if you have some code that, runs on x86 processor, it's relatively easy. In some cases, obviously, you have to recompile and that sort of thing to run on the different OS. But the toolchain is really there today. Obviously, if you're running an interpreted language or virtualized language like Java, it's a whole lot simpler to port. And so we also have a team internally that's actually working with ISV. So whenever we have a customer that runs into a particular library or an open source project that isn't available, we'll actually reach out and make sure that we help them get it ported to support on Graviton 2.
What if it's not an ISV? Do you ever have just an open source project? You've got something that's valuable, and it's not really an ISV. It's a smaller project, perhaps an important one. Yeah. And how do you go about bringing those onto the platform?
So it's customer driven as well, and so I think a vast majority of them have realized that Graviton 2 is something that their user base is moving to, and so they've just gone and added the support for it. And in many cases, if the support's not there, our customers will ask, and it'll get done. And in other cases, we'll reach out, and that's everything from working with open source projects, but also working with some of the operating system, some of the language providers. Things like making sure that Python and Ruby and Java are really performant on Graviton. And so we go and test those, and we'll go back and optimizations to the language and that sort of thing to really be able to support our customer base.
Okay. And that's, the key thing, isn't it? The RedMonk tracks programming languages. It's a big part of sort of how we understand the world. And it's an interesting one because there's always cool new things to support. It'll be Rust or something, but there's still a lot of stability around JavaScript, around Java. Certainly Python has been making a huge impact. I guess the good news from your perspective is just that whilst new things emerge from a customer-driven perspective, the top tier is reasonably stable. So you don't have to be supporting a new programming language every week.
Yeah, absolutely. I think with the number of customers using us and the diversity of languages that are out there, issues get resolved very, very quickly. We've certainly seen, when there's a performance challenge or whatever it might be, it's resolved very, very quickly by the language vendors. And we're happy to help there wherever we can.
How easy is it? So we're saying that in some cases, again, back to that barriers to entry. How easy is it if I say to myself, I'm going to migrate a workload? How long a process should that be? What are the expectations there?
Yeah, so I think the first challenge when I talk to customers is they often think it's going to take a long time or that it's incredibly difficult to do. And so my advice to them is honestly, go and find one or two engineers and give them 2 weeks and say, port a workload or an application to Graviton 2. And don't try and go and do the scoping and work out what it'll take. Just say, you've got 2 weeks, port this to Graviton 2. And in most cases, they actually come back and you say, you know what, we've got it running in a few days. And, they're super excited about what they've been able to do. And then normally a few weeks of testing, whatever it might be, and then they're running on Graviton 2. Once you've got that expertise in your team and you've done it once or twice, well, then it's a whole lot faster and you're able to bring more and more workloads. And, we've seen customers now. We actually saw a large enterprise customer, a very, very large enterprise customer port one of their applications from nothing to fully on Graviton 2 in 4 days, which was just incredible to see.
Yeah, no, do you think part of that hesitancy or is really just what we're used to as an industry? Because historically speaking, migrating workloads to new architectures, new processor architectures, was not easy. So, is it partly just, people have got the scars of that era? And if so, are there some developers that are like, hey, it's all in the cloud, we're used to this, it'll be easier? Do you have different kinds of conversations based on, I'm always a bit nervous of gen shift, but sort of, a gnarly enterprise customer may have a different expectation from someone that's frankly a bit more cloud native.
Yeah. I don't know if a lot of the customers even remember the last time they changed processor architecture. Mm-hmm. So I don't think it's that. I think they just look at it as, the word architecture scares a lot of people. There's a lot of unknowns. They say, hey, we wrote it in C, we're going to have to recompile. I don't know what the compiler support's like. We've got these, open source projects. I don't know if they support ARM. And, it's really just the unknowns. It's really just, they look at all the work that's taken to get this running on x86. And then they make these assumptions about how difficult it's going to be to move to an ARM-based processor like Graviton 2, and it's really just getting them past that. And once they start looking, they say, "Oh wow, the compiler support, we did that. Hey, all these open source packages and operating systems were actually available, and so this is relatively easy for us to move." And so that's really just getting them past the sort of the assumptions that they make about the unknowns and the timeline in their head. And then obviously with the 40% improvements in price performance, there's literally 40% cost savings on the other side of that work. And so that's very enticing and gets them moving. But you really just got to get one or two engineers and start moving.
So let me prod you on that a little bit because I know you've got an evil plan. So we'll get to that in a second. But the price performance improvement, that's the thing. I'd like to talk a bit about sustainability and energy used in running workloads. Theoretically, at least, we can run the same workloads far more energy efficiently on ARM. And I'd like to hear a bit more about that. Are some customers saying actually it's not just about brute price performance, but there is a sustainability agenda? Yeah. And how do you see that playing out as an industry, in fact?
Yeah, absolutely. And this has been one of the things with ARM from its mobile days is its power efficiency. And what we see today, Graviton 2 is about 2 to 3.5 times more efficient per watt than an equivalent x86 processor. Mm-hmm. So that means, for a workload running on AWS on Graviton 2, you're using about 1/2 to 3 times less power than you would be if you're running on x86. And for many of our customers, obviously everybody's thinking about their sustainability plan and their impact that they're having on the environment right now. And that's an enormous saving. And obviously allows us to make sure that we're much more sustainable within our AWS data centers as well.
Okay. I mean, obviously there's a bit of Jevons paradox, unfortunately. If we give people a lot more power, they're going to use it. But on the other hand, I'd like to see that. We've got all sorts of questions about energy supply and everything else, but I did wonder about those sustainability angles. So, you've spoken a bit about getting over that hump, the sort of activation energy to get people excited about this. You are building a program now to kind of nail that home. The Graviton 2 challenge. What's that about, and what are you hoping to achieve?
Yeah, absolutely. So I mentioned that enterprise customer that came and did a migration in 4 days, and that really sparked something on our side. We said, could we provide sort of blueprints and run books, on the basics for most migrations that developers would have to do, and really challenge them to see if they could actually do the migration in 4 days or less. And so the Graviton challenge is actually a blueprint that's structured over a 4-day program to take pretty much any application and move it from x86 to Graviton 2. And, developers don't have to follow the 4-day program. They can follow it in whatever timeline they would like and what works best for their application. But it's already a whole lot of detailed instructions on how you can go about it, help with finding open source operating systems, open source packages, ISV packages, and then even access to AWS Graviton experts that can help them with the application. So developers are able to sign up, and we're able to help them through that migration process.
Okay. And are these, we haven't really spoken about this, are there some kinds of workloads that offer the best bang for your buck? It's sort of whether that might be, data heavy workloads. You mentioned instances with a lot of memory. If I'm a developer saying, maybe I'll give this a go. Are there particular workloads I should think about that might offer me the if I'm that, you mentioned the team going off and migrating, which ones should we look at, or is it just general purpose?
Honestly, like the breadth of Graviton 2 has been one of the things that's surprised us on the AWS side as well. The performance was a surprise just to see how amazing it was when we got our hands on those processes for the first time. But then the breadth of that performance improvement has been just incredible to see. And so, a lot of the customers obviously are running sort of web-based applications, right? They're running web servers and traffic processing, that sort of thing. There it's relatively straightforward to get the 40% price performance improvement. But we've also seen it with other workloads, like, as you said, the large memory workloads where customers are running open source database platforms, the majority of which have also been ported now to run on Graviton 2. And their customers are seeing the 40% price performance improvement as well. Or even like in-memory caching. The other one is, we're seeing a growing segment now in the high performance computing space. We actually launched a Graviton 2 based instance with our 100 gigabit networking, support, which is something that the HPC customers need. And so we're seeing a number of HPC workloads even move to Graviton 2. And so, as long as really it's anything that can scale out, where, you're running multi-threads, typically across a distributed system, multi-threads in a database environment, that's where Graviton 2 really excels with its 64 Neoverse cores that it uses. And so, the breadth, often like customers say, really, Dave, is it really that broad? And the answer is yes, like it is really that broad. The vast majority of workloads are actually seeing that 40% price performance improvement that we talk about.
Okay. So now my friends at Honeycomb, Liz Fong-Jones has spoken highly of the platform. Clearly, data-intensive workloads, observability. They were too early. They did all this before you had the Graviton 2 challenge. But I think the results they've had. Let's just say that I think they, as a team, they are sort of engineers, and if something is not good, they're definitely not going to say it is. So I saw that as pretty good signal in terms of the possibility of doing things with data-oriented workloads.
Yeah, we were, obviously they weren't, they were long before the Graviton challenge, as you call out, but it's companies like Honeycode and SmugMug and Snap, to name a few, that have really inspired us to, look at the Graviton challenge and see what we can do to really broaden this, because they were early adopters. They saw the value. They really leaned in. In the case of SmugMug, they actually did one of their ports in a single day. We launched Graviton 2, and the very next day they moved their web stack to it. And so just the speed that they were able to move at, and then the performance improvements they were able to see, and the cost savings they were able to see from that, sort of inspired us to come up with the Graviton 2 challenge.
Okay. Well, SmugMug, I mean, they're always your earliest customer of everything, aren't they? I mean, they don't mess about.
They don't mess about. No.
So incentives. Obviously from an organizational perspective, there's the, hey, we could do this. We'll hopefully get this performance improvement. But what are the incentives in this program? I mean, there's a bit of a call to action here. We're chatting. You've got an agenda. Getting people to try it out. What, other than the goodness? What are the incentives you've got in the program? I mean, the support in doing it is valuable. But why should I, as a developer, want to get involved in your challenge?
Yeah, absolutely. So, obviously there's the 40% price performance, which I think I've mentioned numerous times, and that's the big benefit. But we also thought we'd make it fun, right? We thought we would add turn it into a bit of a contest. And, as folks take part in the program and tell us about what they're building, we came up with a couple of prizes in a couple of categories. And so a couple of the categories include sort of best adoption awards in the various classes, so enterprise, small and medium business, and startup segments. We also have best new workload adoption, most impactful adoption, and most innovative adoption, or some of the different categories you're looking at. And some of those prizes, there's a sort of main prizes include a trip to reInvent 2021, which is going to be later this year, sort of late November, early December in Vegas. And we're also looking at best adoption winners. Will also get an opportunity to actually present the work that they did in porting to Graviton 2 during a session at reInvent, a live session where they'll be able to tell all of our other customers about what they were able to do. So those are some of the incentives. There's a number of other prizes as well, but those are some of the main ones.
Okay, so if they do something completely amazing, do you get to meet Werner? Might we have a challenge winner in a keynote, or Is that expecting too much?
Maybe, you never know. We'll have to see. I think if it's completely amazing, I'm sure Werner would be more than happy to take a look and see what he would like to include there. So it's definitely
certainly his keynote last year from Amsterdam. That was really fantastic.
Yes.
I mean, I think that was one of the we've had a lot of pretty, somewhat dull, keynotes where you're not in the room. But I think that that was amazing what he put together.
Yeah.
Okay, so session potentially at reInvent, prizes, all that good stuff. Clearly, that's your call to action. I was just going to say, Dave, it's been a real pleasure hanging out with you today. Hopefully we'll speak again. As we go through. I'm quite interested to see how the competition goes. There is some vague rumors rumbling around that I might be doing some judging. We'll see about that.
Well, excellent. That's good to hear.
Only rumblings, mind. I'm obviously angling for it. But it's been great talking to you today. Thank you very much. And that's another Red Monk conversation.